All right, welcome back to another LeetCode problem. We're looking at the second easy problem in the math and geometry section of the LeetCode 150 list. This is LeetCode 66 plus 1, and we're given a large integer represented as an integer array digits, where each digit is, at position I, we have the ith digit of the integer. The digits are ordered from most significant to least significant in left to right order. The large integer does not contain any leading zeros. Increment the large integer by 1 and return the resulting array of digits. Okay. Let's take these examples. Let's have a quick look at the constraints. So there's at least one digit and doesn't have any leading zeros. So right, here is the drawing board. Very nice. Now, let's see what's going on. So here we have the number 123, and we should return 124. All right, and it's giving that order. From the bit problems, you should remember how to do an addition with the carry bits. But just to remind you, so if you want to add a number, well, we're essentially adding the number 001, which is just the number 1. And here we just add them on this digit, and there's no carry. That's why this is easy to compute. Now, if we have this value, it's also easy. We just have to add 1 to the least significant digit, and it becomes a 2. That's very nice. Now, this is the tricky case that we need to solve. So now we have a 9, and we want to add a 1. Well, 9 plus 1 is, of course, 10. And is 10, right? So, and the 1 is going to be the carry, and this is going to be, the 0 is going to be the digit in the result, which is exactly what we see here. Right. So, since we're trying to solve this problem in Python, well, how do we do this? We could insert a number maybe at the very beginning of an array, but that's an operation that is linear in the amount of digits. So the question is whether there's a more elegant way of doing that. And I think there is. So what we can do is, we can add, let's do something with a little bit of indexing magic. So what we can do is we just add the 1 to the last digits. We compute if there's a carry, and maybe the carry propagates through the whole thing. So let's say we have 999 and 9, and then we want to add 1 to it, right? So what will happen is, well, we get 0 and 1. So 1 will be our carry. This is the digit. Now we get the same thing again, 0 and 1. 0 and 1. 9, 0 and 1. And the last one, this one here, doesn't fit into the array because we only have 4 places in our array. But we've updated all of the other ones with zeros. So where do we put this here? Well, how about we just put this here? At the end. Just add this here. And then we just rotate the entire array to the right once. How about that? So that would be doing it in place, appending one element, which is constant time. And then we just rotate the array by one place, which can be done in place as well in O of length of the array time. Another way we could handle this is, if we were to reverse the array in the beginning, and then we just add, with the 9s, it's kind of weird because all of these values are the same. But if we had an 8 here and then we added 2, what we could do is we could reverse the entire array first. We have 8, 9, 9, 9. Then we say plus 2. And all of the values that we compute would be 0, 0, 0, 0, and 1. And we could just append this one here and then reverse. Or we would append this here and then just reverse the array. So it becomes then 1. That's maybe even easy. Yeah, why don't we just do that? Yeah, then we can just iterate forward through the entire array. Right. So that is what we will do. Cool. So we will say, oh, how do we do this? Well, we don't want to create a new array, so we have to reverse the array first, right? So we need a little helper function for that. Reverse array. I'm gonna program this by foot. For I in range length array. We only need to iterate over half the elements, but we do have to do a +1 because the end of the range is not inclusive in Python. And we just say, well, we have a variable j. Actually, we do a left-right pointer. How about that? Left equals left and right. Left is 0, right is length of the array, -1. And then we have a little while left is smaller than right. While that is the case, we're going to swap the elements. Array at left, the left position, that's going to be array right. I could type. Swap their values, like so. So the value of array left becomes the one that is at array right. The value at array right becomes the one that is at array value left. And doing this in a one-liner ensures that we are first reading out the values and then assigning them so that we don't lose a value. Right, so we need a little reverse array. So, and we actually don't have any side. We don't need any return values. We just say reverse array because this method here is a method with side effects, and the side effect is that the input parameter will contain a reversed array. Now we would do our addition, and at the very end we kind of have to reverse the array back, right? So we will do that. Reverse, and we return the area. Cool. So now how we do the addition? Well, easy peasy. So we know we need to add one. So our carry in the beginning, we initialize it with 1, right? And then we iterate over all of the values. For I in range length, it's. So we will do some math here. And if in the end we have a carry value left, if carry, we're going to do digits and 3. Yeah, that's the magic. And yeah, so what do we do now? Well, we'll compute the carry. And we have to compute the digit, right? And then we have to update the value in the digits array with digit we need to do. So what is carry? Well, carry is digits plus current carry. And what becomes digits now? Well, it's carry module carry itself is going to be integer divided by 10 as well. So if we have 9 and carry is 1, this becomes 10, carry becomes 10, the digit becomes 0, and then we're going to left shift or right shift carry in decimal by 1 position, so it becomes 1 again. And yeah, that's how we do this. And we don't actually have to store the digit, we can just write it directly back. So that we just have to deal with updates here and updating our carry value. And I think that should work. So let's run it through the first tests. No, it's not called array, it's called digit. Again. Oh no. Length of array. Again. Oh, this is an infinite loop here. So we have to increment the left counter and the right counter we have to decrement. Otherwise it's not gonna work. So that's now time limit exceeded. Let me try again. Right, so passes the test cases. Very nice. Let's submit this. See if it passes all of the tests. And it does. Really nice. And took 0 milliseconds. Amazing. So, well, what is left to do? Well, time and space complexity analysis. Time and something space. So, well, how much time are we going to need? Well, if we say that n is the length of the digits, right? So we're not saying n is the number that is stored in digits, but n is the length, so the number of digits itself. Well, to reverse the array, we need n time, right? And we're going to reverse it twice, but that's still n time. And then we need to iterate over all of the digits exactly once. That's also n time. And that's pretty much it. And in terms of space, well, I would say it's constant space because we are reusing the digits array. We're not allocating a new array. At most, we're adding one element to the array. So this gives us a nice O of n time and O of one space. If you were to say that n is the number stored in digits, then it's actually, you could say this is a log n time and still O of one space. But I think this is the more accurate way to do it. And yeah, so that concludes this easy problem.